Hello and welcome to exercise 4D, trigonometry with obtuse angles. So before we begin, we're going to recall how to solve trig equations to find an angle. If we have the trig equation sine theta equals 1/2, we need to undo this sine function that's acting upon theta. And the only way we can do that is by taking the inverse sine. Okay. So what we're going to do in our calculator is press shift, sine, and then 1/2. Okay, and that will get us to this point here. So in our calculator we press shift, sine, and we get the little minus there, and then we type in 1/2. And when we do that, we can just simply press equals, and we will get 30 degrees. Okay? Just like that. So our angle is 30 degrees here. Another bit of recall we need to do is acute and obtuse angles. So an acute angle is an angle that is measured to be between 0 degrees and 90 degrees. And that's our diagram on the left here. And an obtuse angle is an angle that's measured to be between 90 degrees and 180 degrees. And that's our diagram on the right. Now, the Cartesian plane, also known as the XY plane that we're familiar with, is comprised of 4 distinct quadrants or quarters. These quadrants are named 1 to 4. 1, 2, 3, 4 in an anti-clockwise direction. Okay? And these dictate where specific types of angles are. So for example, the acute angles, 0 degrees to 90 degrees, lie in our first quadrant here. So we have 30, 60, and 90, all in this first top right quadrant. And then obtuse angles, from 90 degrees to 180 degrees, lie in our second quadrant, which is the top left quadrant, the top left quarter. So we've got 120 degrees all the way to 180 here. The link between the quadrants of the Cartesian plane, the angles associated with each quadrant, and trigonometry is that these angles determine whether a trig ratio will be positive or negative. So when the angle theta is acute, between 0 degrees and 90 degrees, all the trig ratios, sine, cos, and tan, are positive. However, when the angle is obtuse, so it's in that second quadrant between 90 degrees and 180 degrees, the sine ratio is the only one that is positive. The cos and tan will be negative. For example, pressing cos 120 degrees on your calculator will result in negative 0.5. Okay, because 120 degrees is an obtuse angle, and that means that cos will be negative when you use an obtuse angle with it. However, pressing sine 120 degrees will give you a positive result of 0.866, because sine is positive when you use obtuse angles. Now there's an easy way to remember this because it seems a bit complicated, and that is remembering the phrase all stations to central, all stations to central. And now, if we take our Cartesian plane down here, and we start here, we start in our first quadrant, and we label that with the first letter of our phrase, so A for all. Okay, we're moving around in an anti-clockwise direction to our second quadrant, and I'm going to put the first letter of the second word in our phrase, which is an S. And then I'm going to keep going around the circle, so T for the third quadrant, and the third letter, third word, and then C in the fourth quadrant for the fourth word. So what these actually stand for are all, okay, sine, tan, and cos. Now, these determine whether in which quadrants our ratios are positive or negative. So in our first quadrant, A, all of them are positive. Okay, that's why it's an A. In our second quadrant, S, that means only sine is positive. And in our third, T for tan, only tan is positive. And then our fourth, C for cos, only cos is positive. And this just reiterates what I've just said. So first quadrant, A, all are positive for acute angles. Second quadrant, S, Obtuse angles, only sign is positive. And you can remember the T and the C as well, but in our level of mass, we're only going to use the first two quadrants. Okay, so we won't have to worry about those two. And here's just a little summary. So acute angles, all are positive. Obtuse angles, only sign is positive. Now we'll have a look at some examples. Find the value of the following obtuse angles correct to 2 decimal places. Now we can simply evaluate these ratios here with the obtuse angles in our calculator. But let's think about where they're going to be before we do anything. So we have two obtuse angles here. Sine of this obtuse angle of 164.25 degrees. That's going to be in our second quadrant because it's obtuse. Okay, and since we have sine, that means this is going to give us a positive answer. But this one, 124 degrees and 30 minutes, that's also an obtuse angle in our second quadrant. But tan is negative there, so tan of that obtuse angle will be negative. And that's exactly what we've done here. So sine of our obtuse angle gives us a positive answer. Tan of our obtuse angle gives us a negative answer. Example 2. Finding an obtuse angle from a trigonometric ratio. Given cos theta equals negative 0.5178, find the value of theta to the nearest degree. And B, given tan theta equals minus 1.32, find the value of theta to the nearest minute. Okay, so finding the angle for A, our first one, is quite simple. It must be obtuse since cos has a negative value, so cos of our angle we're finding is negative. That means that this angle must be obtuse. Okay, so it's in that second quadrant we were talking about before. And we can do the same sort of thing for B. So tan of our angle is negative. That means it must also be an obtuse angle in that second quadrant. Okay, because we've got a negative result. But it's a bit trickier to find that one out, so we're going to leave that till last. And that's just what we've said here. So, solving for A, cos theta equals negative 0.5178. To get from this line to our next line, we have to take the inverse of cos, okay, to both sides. So the way we do that is by pressing Shift, cos, typing in negative 0.5178, and then pressing equals on our calculator. When we do that, we'll be typing this in on our calculator, and when we do that, we'll get theta equals 121.18479, blah blah blah. And now we want to see it to the nearest degree, so I'm going to press the degrees, minutes, second button located on your calculator, and that will give us this, 121 degrees, 11 minutes, and 5.26 seconds. And now it's the nearest degree, so looking at this, I don't have to round anything up, so I'm going to leave it as theta equals 121 degrees to the nearest degree. Now for the next one, it's a bit more complicated to understand. So the start of the process exactly the same. Tan theta equals minus 1.32, and I need to take the inverse tan. Okay, so I'm going to press Shift, tan, type in minus 1.32, and then press equals. And I'll be typing that in. That's what it will look like on our calculator. And then that will give me a negative answer of negative 52.85, blah blah blah. Now, problem with that is negative angles don't really make sense to us at this level of mass. Okay, so what can we do? Well, we know that tan is negative. Okay, we know that this angle has to be obtuse because that's where it will be negative, in that second quadrant where the obtuse angles are. Okay, and that's exactly what I've just said here. Negative sign tells us that the angle is in the second quadrant where the obtuse angles are. So what do we need to do? If we go all the way back here, if we think about 0 being this line here, that negative 52 degrees or whatever it was, would be down here somewhere in this quadrant. We need to add 180 degrees to get it over to here. So we'd go halfway around our compass, or our Cartesian plane, in like a circle. We add 180 degrees and go halfway around the entire thing, and we end up with the obtuse angle that that negative thing represents. Okay? Which is a little bit tricky to understand, but let's give it a go. Here we go. So, to find the obtuse angle, we have to add 180 degrees to our negative angle. Okay, so if you didn't understand what I just said, all you have to remember is if you get a negative angle here, you have to add 180 degrees to it to find the obtuse angle. Okay? And you can write it just like this, 180 minus that, because all I've done is gone 180 degrees plus minus 52.85 blah 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 degrees. Okay? That's exactly the same as writing it minus 52.85 plus 180. And if we do this on our calculator, we get theta equals 127.1466867 degrees. Now, to find the nearest minute, we need to press our degrees minute second button located on your calculator. And what will happen is we get 127 degrees, 8 minutes, and 48.07 seconds. Okay, so now, because that's greater than 30 seconds, we need to round the minutes up by 1. So our obtuse angle to the nearest minute is 120 degrees and 9 minutes. And I don't actually think you need to add that 0 in there, but it doesn't really matter.